Okay, I am super excited about this, and I hope you are too. I'm sure you know by the title what's in box 3. This is heavy. Okay, so here we are. This is the brand new Bluetti APEX 300. I have two B300Ks with it, and this is what everybody's been asking for. These little short battery jumpers. Look at that, they sit right in there. We're gonna go find some better light and look at this thing pretty thoroughly. And I need to clean all this up before my wife gets home. Okay, so here we are outside with the APEX 300. I'm gonna try not to get in the light of it too far, but I've got it facing into the light and the screen is remarkably viewable. I'm seeing some flashing here, but that doesn't show up in real life. It looks very, very readable in direct sunlight. So we have the only output ports. There is no USB on this at all. The output ports are 4 15-20 combos on the front, 2 of which are fed from one leg of the inverter. Let me try and get out of the light here. 2 of which are fed from one leg of the inverter. You see 1920 watt limit on that one, and the other leg 1920 watts. This unit is 3,840 watts total via split inverter. See, 3840, 2,764 watt hours, which is the same capacity as the B300K. So this unit has a B300K inside it, which is why it weighs 84 pounds. On the front, we have a charging switch, silent, auto, and turbo. I think we're gonna find out more what auto means in a bit. AC on off, turn on the inverter. I just heard it click. Eco, not sure what that does. Looks like that turns on an icon here. Eco looks like it enables and disables eco mode. And then voltage selector, 120 and 240. Just flip of a switch. I heard a click and it changed to 120, 240 here. Now it just says 120. So I've got it hooked up to both B300Ks, and I want to look at the side ports here. So here's our PV input. 12 to 60 volts, 20 amps, 1200 watts times 2. So it is 2 XT60s. So gone is the multiplexed charging cord of the AC300 and AC500. You just have 2 straight up XT60 inputs. And we're going to talk more about that. And then here are the new connectors. And now we know why on the B300K, the battery port is sideways like that. It is to accommodate these connectors. So one connector's in this orientation and the other connector is flipped. And if you were to stack up the maximum of 6 of these that can be connected, you would just have alternating rows of connectors the whole way down. So that is how that works. So also I noticed here we have 2 fans on this side and a removable via a screw, a removable fan screens for cleaning, I guess. That's very, very nice. Here's the back. Number plate. And if we remember, the B300Ks have these mounting screws, mounting studs. Look here, mounting studs that match. Same vertical alignment. I mean, the spacing here, but same vertical alignment. So that, I have not yet seen any hardware or bracketry announced, but you can mount the whole thing, including the head unit, to something. Here's the input side. So we have 2 more fans. So this unit has 4 fans in it. Same removable screen. There's a circuit breaker. And this is what I could not show on my CES video, but it has a C13 input port for 120 volt input only, 15 amp max. Here's the custom port, the new custom port, AC in out 120, 240, 50 amp maximum. So this is a combination input, output, and data port meant for the paralleling hub, the A1 hub they're calling it, where you can connect up to 3 of these APEX units together to get a true 50 amp input and output. Here we have a 120 volt 30 amp TT30 port. I will be using that. And here we have a 120, 240, 50 amp. This is a NEMA 1450, commonly found on your range and or your motorhome. 50 amp, 120 and 240 combo outlet. So that is a walk around of the APEX 300. Okay, here's something I wanted to show before I lost the light, and I realize there's a lot of backlight going on, but look at this. AC 300 on the right, APEX on the left. The AC 300 is taller than the APEX. They are the same width, give or take. They are the same thickness, front to back. The APEX has an internal battery. It has a B300K inside it and a larger inverter. How's that for progress? Wow. Welcome back indoors. So we have just concluded one test and I'm getting ready to start the second one. The very first test I did was what happens if you use APEX as a standalone UPS. So what happens if I just set it to standby UPS mode, let it fully charge the battery, and plug my computer, my refrigerator, you know, all that sort of stuff into it. What is its cost of use? How much overhead power will it consume? My APC UPSs, you know, consume 27, 30 watts. I've converted one to LFP and now it consumes 9 watts of standby power because LFP batteries do not require the constant trickle charge that lead acid batteries do. So I've done that test with this. I brought it in the house, plugged it in, let it sit for 24 hours at full charge to equalize and balance the battery as best it can. And then I started a power meter, the one in the back there. So this guy is, let's see, I've turned it off now, but after 24 hours, we consumed 430 watt hours of electricity as a standby UPS. So what that means is you divide that out, 430 divided by 24, that's like 18 watts, 17.9 of average consumption. And these devices, at least the Bluetti devices, they don't pull that constantly. They sort of pulse charge. So it'll pull no power and then it'll pull 300, 400, 500 watts for maybe a minute and then it'll pull no power. So that's it topping off the battery periodically. So that is absolutely in line with Bluetti's published numbers. They say 20 watts of self-consumption, I believe, and we're right there. So I'm going to do a slow discharge test next. So what I've got here is I've turned the inverter on. That is turned off, so there's no power coming into the APEX, no grid input. I'm going to turn on this power meter, which I previously zeroed. And I've got my adjustable power supply here. So we're going to turn that on. And this power supply goes to my rack batteries, which they are in need of some charging right now. So they can easily absorb the 3 kilowatt hours, give or take, that's in the APEX. And I'm going to do a slow discharge at about 500 watts. And I'm going to do that as per whatever the power meter here is telling me. So I'm going to adjust the current up. $298, $350, $400, $470. 485, 497, 499. All right, 499 watts, and we'll let that go. And we are back at the conclusion of that test. I discharged the Apex completely to empty to shut off. Turned off my power meter. Well, it turns off automatically. And then I recharged it with that meter back there from my AC 500. So the total discharged power was 2.342 kilowatt hours, or 2,342 watt hours. So 2342 divided by 2764.8, which is the number down here, gives me 85% of nameplate capacity successfully sent to the load. And then, let's actually do a little side note on that. You may have seen while I was dialing up my power supply here that I was trying to get to a 500 watt indicated number on the power meter. But you actually, if you're looking, you saw more load here. So what that tells me is that the Apex, like a lot of the newer products, its output number reads in VA, not watts, and the difference is the power factor. And this is not a unity power factor device. It actually has a fairly lousy medium power factor. I think it's about 0.65. So I had 500 watts here, and it was showing like 780 on the screen. VA. It says W, but it's really VA. So just a little bit of discrepancy. I'm going to do another test here, which will be straight resistive, and we'll see if we get a different result. Also, that discharge test was with the 120/240 switch set to the 120 volt position, which I found out in watching the discharge through the app. It actually runs both sort of phases of the inverter in parallel. So I was only pulling power out of this outlet here, but when I loaded up the app, and I'll put that over here, when I loaded up the app, it was showing the L1 and L2 inverters both sharing the load that was coming out of here. Just something interesting to notice. We'll do another test with it set to 240, and we'll see that it actually runs each side separately. But I'm going to use two 1500 watt heaters, so we may not actually see much of a difference. All right, and then so after that, I charged it up completely using the C13 outlet on the or inlet on the side at I think 1469 watts. Its rated maximum input 12 amps is all I could get it to take. It says 15 amps on the side, but I could only get it to take 12. To do that, we absorbed 3,323 watt hours, 3.32 kilowatt hours from my AC 500. So if we divide that, it is 120% of the nameplate capacity here is what it took to charge it up. And that was at a pretty quick rate. It charged up in just over 2 hours doing that. Okay, let me reset this, zero the meters, get some heaters up here, and we'll start the next test. Here we go. I've got my two 1500 watt heaters, each one wired to a power meter. They are zeroed out. Everything's turned on. The Apex is at 100%. I unplugged the input cord from the side. This is going to be a straight battery discharged at about 3,000 watts. So let me turn on the first heater. And there will probably be some surge beyond 1500 as it gets up there. 1509, 1511. Let me turn on the second heater. $3,200 watts, 31. All right, we're gonna let this go. I'll see you back in probably about an hour when it's empty. And we're back. We had completely discharged the Apex to empty through my two heaters there. We've got data recorded, and I did that in 240 volt mode. I think I did a screen capture. I'll put that up here so we can look. It's interesting to see though, each heater is they're separately metered. They're, slightly different brands. So it was differently loaded per phase. So I did, inverter 1, inverter 2 testing. And here I stuck my multimeter in, and we can see that we are in fact getting 250 volts, 248. It's, varying a little bit. But the Apex is currently being powered from my AC 500 via 120 volts. So it is up converting 120 volts to 240. And by the way, let me get this heater out of the way. The AC 300 is absolutely killing it today. 2,300 watts right now it's bringing in. So I'll apologize if the fans bump every once in a while. It's quiet now, but it'll run the fan on low every once in a while. So let's get back to our discharge test here. So power meter, this is L1, this is L2. So power meter 1, 1,267 watt hours. Power meter 2, 1,105 watt hours. The combined total is 2,372 watt hours. Divided by 2764.8 equals 85.7% of the battery rated capacity. And that's at, that's 1,000 watts shy of its full load rating. That's, 2,800 watts total out of 3,840. So we're right there at the heavy load testing. And recall the light load was 500 watts, and I got 85% of rated output. So something interesting to note also, by the way the Apex does the up conversion to 240 is the 120 volt C13 input on the side goes to the L1 inverter. And then to get the other side, the other 120 that makes the 240, is it uses that inverter as a charger. So it sends it across the DC bus, and then it runs the L2 inverter to generate the matching 180 degree out of phase waveform to get the 240. So that has some interesting complications. We're going to go take a look at that more closely. And now I'm going to try my best to channel Big Clive. So we're going to review types of UPSs and like architecture of UPSs. So the first and most basic type of a UPS is what's called a standby UPS. And this is your traditional APC desktop units, CyberX, CyberPower, TripLight. They're standby. So they have their grid input, a bypass line that goes all the way through the UPS, a switch, a transfer switch, and then your output. On that bypass line is a charger, which runs all the time when you have grid input available. It charges the battery, and the inverter is just sitting there, not connected to anything. This switch is normally in the up position. If grid input goes away, the charger also goes away, and then what happens is the battery and inverter switch into the circuit, and it powers your load. And these units typically have a transfer time of 15 to 20 milliseconds, and that is sort of the industry standard. The next and most interesting type of UPS, this is more of the industrial type, is what is called an online double conversion UPS. So in this system, you have your grid input, just the same. It feeds full time into a rectifier, which then passes that power through a DC link, which has the battery connected to it. And then the output section is an inverter, and then that goes to your load. What this system does is, through this conversion process here, it filters out a lot of noise, garbage, stuff on the input. So the load only sees what the inverter is producing. It never sees the input grid power. This system also has an advantage in that if the grid goes away, the rectifier goes away, the load is already powered by the inverter and the battery. There is zero switchover. The load never even notices it. The downside of this is there is conversion loss. If you have 100% coming in, you have AC to DC conversion here, and then DC to AC conversion here, and you typically get 80, maybe 85% of your output power that you got in, 80% give or take efficient. So that is, think about this. Okay, so this is what a typical modern Bluetti system looks like. It is more or less a standby UPS, but what they have done, instead of having the charger and inverter be separate pieces, it has a bidirectional inverter. So what this does is it allows the inverter to run as a charger, and that's how they can charge at pretty high rates, and then the inverter will reverse direction and supply the load. Typically there's an input contactor before the inverter, and then there's an output contactor after, and that allows you to charge without having the AC output turned on. And it also, when the grid input goes away, it opens this contactor so it's not backfeeding power to the grid plugs. So that goes away, transfers, and this typically has the same 15 to 20 millisecond transfer time, because you have to open a contactor and you have to reverse the direction of this inverter. I think the inverter switching is faster than the contactor. I think the contactor is typically the slowest part. So what does Apex do different? Well, Apex adds a whole nother bidirectional inverter string, actually, a whole setup. So it has what we'd call, well, what it adds in order to make the 240, this grid input becomes grid L1. This grid input becomes grid L2, and this is load L1 and load L2 as referenced in the user manual and in the app. If you feed Apex with the two opposing 120 volts, oh, by the way, also this bidirectional inverter is connected to the same battery in the same way. Actually, it's probably more like that. The battery just comes off a common bus that they're connected to. If you feed Apex with 240 volts, so if you got like a neutral here and it's 120 that way and 120 this way, these contactors close, and you're feeding output, and the inverters can pull off of their respective 120 volt line to charge, and they can supply off of their 120 volt line in like self-consumption mode. What makes Apex so unique, and well, in this function, Apex is a standard sort of standby UPS. If input power goes away, these contactors open, these inverters go to supply, and you've got 20 millisecond give or take transfer time. What makes Apex so interesting is if you run it in 120 volt only mode. So there is no L2. So you've got it in, you're feeding it with 120 volts, but you have it switched to 240 volt output. It makes 240 volts. How does it do that with only 120 volt input? Well, it sends this 120 volts through to your output, but it uses this inverter as a charger to supply DC power to this inverter, which it then synchronizes to form the opposite 120 volt waveform to get your 240, and it sends that out here. So what does this look like? It's this. It is an online double conversion UPS when you're feeding Apex with 120 volts, but have it set to 240 volt output. In that situation, this side, the L1 side, which according to the user manual are the right two outlets on the face of the unit, that is a conventional 20 millisecond transfer. But any 120 volt loads you have connected to the L2 outlets, which are the left two facing the unit, those have 0 millisecond transfer time because they are already being fed from the battery and the inverter. Isn't that something? Let's take a quick look at the Apex 300 integration in the Bluetti app. Starting at the top, PV. This unit has two inputs and they're both shown. And then the grid. This is new, so we see power frequency and then L1 power voltage, L2 power voltage. So we have separate metering. By the way, for the purposes right now, I do have power on the C1314 input 120 volt input cord. So that is what we see reflected there, is that input goes to the L1 inverter. Let's tap on the battery icon. So we see a different layout, but we're showing the input, or I'm sorry, the internal battery here. If there were external additional batteries, they would be listed down below. DC, there's a question mark. No DC hub connected. That's because this unit has no native DC output. We'll be looking at the DC hub a little bit later. AC. So here we have output power for L1 and L2, metered separately, separate voltages. Scrolling down, components. This is interesting. This is, I believe, where the smart plugs would integrate. I don't have any of those. We've got your standard countdown time, PV generation. So let's go into settings here. Working mode, you've got your standard UPS modes. Notice these are listed a little bit differently. So instead of, this is sort of listed in the EP 800, 900 nomenclature. In the portable power station version of Bluetti products, backup is standard UPS. Self-consumption is what we would normally see listed as PV priority. And then you've got time of use, which is where you can put in your time zones, time of use. And then you've got custom, which is the same custom UPS. So we're going to set that back to standard UPS. See, it says select UPS standby. There is no option for that. Extreme weather alert. This is a new feature. If alert is detected, this is something we have been asking for, storm guidance to set the unit to charge. Very nice. It is currently enabled. You just have a disable and an enable. Charge mode, standard, silent, and turbo. The standard charge mode is 1440 watts. Silent is, I think, like 5 or 550. Interesting that it sends me right back out of the menu when I selected that. And then turbo. Turbo will unlock full power charging, but you need to have the high current input cords to do it. It'll charge it up to 3,840 watts from the optional 240 volt cord, or 3,600 watts, I think, from the 30 amp 120 volt cord. Also, similarly to other modern Bluetti units, the charge mode does impact the solar. So if you have 2,400 watts of solar hooked up to this thing and you're only charging at 1,440 watts, go in and set it to turbo. Or if you're only charging at 5 or 550 watts, you're probably in silent. So I suggest probably keeping it in turbo all the time, and if you need to modulate your charging speed via the grid input, there's a different place to do that. It has power lifting. It has eco mode. That's useful in some situations. Standard screen timeout. There's a child lock feature. We will hit enable. Yeah, so that's interesting. You can choose what you want to do with that. Standard firmware upgrade, firmware check. advanced settings. There's a good amount in here. So max grid input, this is common with several of the newer systems. Nice that it shows down below sort of a description of what's going to happen when you have different things set. It has the output frequency. You can choose your output frequency. I'm going to unplug the C13 from the unit so it's not getting input, and then it should let us access that menu. Let me try again. There we are. It just took a second. So you can choose 50 Hertz or 60 Hertz output. Charging station. This is if you're going to use the optional EV charger to feed power into the unit. You can select that and it will disable AC output. AC output voltage. This is a completely new one. So you can choose 208 or 240 output. System switch recovery. This is where the unit will power or turn the inverter back on and re-enable output. If you run the unit to empty, it does want the Pro Mode password for that. Grid self-adaptation, currently disabled. But look at all the settings in here you can do. You can choose your PV input source, others PV. I can tell you if you go into Pro Mode, it gives you quite a few more features, but I'm not going to display that password. Okay, we've got Apex on the road. I'm over at my neighbor's house with his electric car. And one of the things that's advertised that you can do with Apex is charge vehicles. So we decided to try it and also load test it because I think we can overload it. So we did do some testing and found out that the mobile charger here does require a neutral ground bond. Just it wants to make sure your wiring's good. And Bluetti power stations, as almost every other portable power station and portable generator, are floating neutrals. It's just how they're designed. So I have my neutral ground bonding plug, and we will connect that to any outlet you choose. It doesn't matter because the neutral and the ground is common through everything. So we have the mobile charger here with a TT30 plug on it. So we will do this test at 120 volts first, and I will connect that to the TT30 output. I will make sure I'm in 120 volt mode. I will turn on the inverter. And I've got the app here, so I will put this somewhere and we will plug the car in. If I don't braid myself up here too badly. Car is blinking green. Nothing yet. It'll take a minute to walk it in. I just heard the fans kick on. 1900 watts. Let's tap for details. $34.16 watts. What are we set for?
32.
32 amps. So that's the full rating of Apex. There, it took a bit for the screen to update on the app. 3769 watts. We're right there. We know Apex will do that all day long. We cannot overload it with this plug because that's a limitation of the mobile charger. With that plug, 32 amps is all you can get, which is actually over spec for that plug anyway. So we're gonna shut this down and convert to something a little beefier. This is the NEMA 1450 50 amp connector. Turn off AC output. Remove the TT30. That is firm. Switch to the 1450. Now Apex will provide 240 to this plug, but it cannot provide 50 amps. If I had 3 Apexes in parallel, we could fully power this plug, but just one, we can give it 16 amps at 240 volts. So I will switch to 240 volts. I will plug this in first. And we will turn on the AC output. And my neighbor here is going to adjust the charge power so we don't immediately overload it.
It's on 16 amps.
113 watts. Sort of. I just heard the fans kick on. Oh, by the way, Apex has 4 fans. It has 2 on this side that blow out and 2 on this side that pull in. So that's both redundancy and quiet. 3785 watts. Now we can see here that the phases are different. L1 and L2, slightly different voltage, a watt difference between them. That's neat. Shows on the app that we can do this for 30 minutes before we're empty. So we're right at the rating. We're very near to it. Let's see if we can overload it. Can we dial up to 17 amps? $4,049 on the screen, $4,059 on the app. It's bouncing around a little bit, 4048, 4057. So we are now in the overload range. It seems fine. It's probably started an internal countdown, so it'll give me like 2 minutes if it's like the AC 300 and 500 it'll, before it shuts down. Let's see if we can do another amp. 18? $4,290 watts. 4,290 watts out of this thing. It's not beeping. It didn't shut down yet. It'll probably do it for another minute or two, but it'll eventually shut down. Apex is impressive. This is neat. This single unit will not charge this car all the way up, not even close. This unit with 2.7 kilowatt hours in it, maybe, well, we did the load test. This car consumes about 250 watts or 250 watt hours per mile. So we might get 8 or 10 miles out of this thing. But you could do more batteries, you could do a lot more and get a meaningful charge into your car, but it works. Welcome to some more actual real-world parts of this testing and demonstration. Before we get to running my house off of Apex, I wanted to show you something that just came. This is the DC hub. Remember I said that the Apex has no built-in DC output. This is the solution to that. This is connects to the battery port, the P090D connector, and it has 2 12-volt outputs, cigarette lighter style, 2 DC 5521 barrel connectors, a pair of Type A USBs here, and a pair of 100 watt Type Cs over here. It is selectable between 12 and 24 volts, and this is what is going to make everybody in the camping world super happy. It has a 50 amp Anderson connector on the bottom. So that is 50 amps at 12 volts, 25 amps at 24 volts. And it just connects right into the battery port. I have the Apex sitting on top of the 2 B300Ks just to make it a little more workable height. I am not going to be using those for this demonstration. I am just going to be using the Apex and its built-in battery. But let's connect the hub to the Apex. Click it to lock. Push the on button, comes on green. Green indicates 12 volts. The hub also connects very nicely. Oh, cable's in the way. Connects very nicely to the side. It'll clip on the handle on either side. Also, this bracket is removable. There are a couple screws to loosen it. This bracket comes off, and there are mounting slots on the back, so you could mount this on a surface. But let's look at the app integration of that. So I'm in the Bluetti app right now, connected to Apex. The DC output was gray before. Now it says 0 watts DC. If we tap on it, look at all this information. We've got cigarette lighter A, power and voltage, cigarette lighter B, power and voltage. The Type C's are metered independently. The USB-A ports are metered, and the Anderson connector is metered. There are 1, 2, 3, 4, 5 different things that are metered in this. And we can remotely control it. We can turn it on and off in the app, just like any other built-in DC. This thing does so much, I'm going to be doing a separate video on it in depth. So this is all we're going to cover of the Hub D1 right now. So back to the power testing. So pretend the storm happened. I know it doesn't look like it did, but pretend my house does not have power right now. I wheeled the Apex outside just because it's nicer outside, but I could do this inside and just run a cord through that window back there. But we're going to do some 240 volt testing. So I've got my big cord. This is L1430. It connects to the generator inlet right behind me. And on the other end of it, it is also L1430. So this will connect to most standard high power generators, and it'll run my house. Apex does not have an L1430 on it. It has a NEMA 1450, 240 volt, 50 amp rated connector. So I'm going to put this adapter on there that lets us run that from there. I will connect it to Apex, and I will connect it to my house. All right, let's turn on AC output. And also, I do have Apex connected to solar panels. You can see on the app here, 482 watts of incoming PV. So let's talk about that actually first before we go in the house. So I have it connected to PV1 here. What I have is my portable all powers 600 watt solar panel. It is the SP039. To my knowledge, it is the largest folding portable panel that exists. And it has a very, very high open circuit rating for a portable panel. I think it's like 54 volts. The Apex is limited to 60 volts. It'll take 60 volts at 20 amps on each of the two PV inputs. And that is going to be very, very hard to make. I considered running Apex off of my larger array upstairs on the deck, but I would have to do quite a bit of reconfiguration because that has two different arrays that are like 115, 120 volts each. So I'd have to redo it all like in parallel. And that's a pain. So we're running Apex off of the SP039, such as maybe you would if the power went out and you had a folding panel in your basement, and Apex, you just brought it out in the yard and hooked it up and hope to run your house. So that's what we're gonna do. So Apex is on, AC output is on. We are in 120 volt mode. So let me do that. I'm gonna turn that off. We're gonna switch it to 240. We're gonna do some 240 volt testing here. Turn the AC output back on. 240 volt. 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 Okay, so we are at my main panel here. This is my transfer switch that is currently running most of the important 120 volt loads in my house off of the AC 500. What I'm going to do is, this is mostly a 240 volt test, so I'm going to turn off my AC 500 input, turn off my air conditioner because I don't want that to run. We're going to test the dryer. Yep, we'll leave the rest as is. So I'm going to turn off the main up here, turn on my generator inlet. Oh, by the way, the basement lights are currently fed from the AC 500. Okay, I just heard utility power come back. Let's go play. Okay, the first thing I want to know is, will Apex run my electric clothes dryer? This is on a 30 amp cord. We'll see. Let me turn it to find a cycle that lets me select various heats. We'll say extra low heat. Let's see if that'll do it. It comes on. And we just kicked off. We tripped out. Too much for Apex. Okay, so the dryer did not work. Let's try my range. This is a full induction KitchenAid. Every burner on this is induction. Oh yeah, those are for something else. So every burner on this is induction. The big burner here is like 3.7 kilowatts, give or take, I think. The small ones are 1.7, 1.6, I think. There's a medium one back there. So let's try first with the small burner and see what we get. On, dial it up. So what this range does is that at lower loads, it cycles the burner on and off until it reaches a certain point that the element can stay on, and then it does. So I'm looking over at the Apex display on my phone here, and we're at 1 kilowatt total load. Let's turn that guy all the way up. Boost. That is all of the extra. I'm seeing 2.2 kilowatts. Very nice. Let's see if we can get some load detail on that. Okay, let's look at the big burner. What does that do? $3,100 watts. Apex will run an oven. This oven is on a 50 amp plug, and the sticker on it says it will pull 12, it is rated for 12.6 kilowatts. So Apex can definitely not do everything that this oven can pull, but we can run some burners on this oven. Let's see if it'll run. You turn the little burner off. Let's turn the big burner up. High. What do we get? The app is slow to update. .1 kilowatts. See if we give it everything. 2.6. So this is running at 240 volts. 3.8. Whoa, there we go. It took the app a minute. So 3.8 kilowatts. So that's this burner plus some other 120 volt stuff in my house that came on, such as the lights here in the kitchen. All right, let's turn this off and go do some other testing. So that's Apex running my house on 240 volts. I did try it on my electric dryer, even at the lowest heat setting. It wouldn't do it. It tripped out. I'm not sure what the dryer pulls. I have not, amp clamped it in the panel. So single Apex, not enough for at least my electric dryer. My guess is it's 4,000 or 5,000 watts. It is on a 30 amp plug, so up to 24 amps continuous off that. Who knows if it actually takes even more. So what we're going to do next is reconfigure Apex for 120 volt output to my house. This is how I have run my AC 500 and AC 300, and you saw me out here with the AC 200L even doing it. So we're going to turn off the AC output. We're going to flip the selector switch to 120 volt operation. I'm going to disconnect this cord and my 50 amp plug on this side. And I'm going to use the same cord I used for the other demonstrations. And this is a cord that I made myself. It has a L530 on this end, with a TT30 adapter, and then this end is L1430, which is the same as that cord and the same as the house. What I've done to this cord is bridge the hots in this connector, so 120 volts in on this side will give you 120 volts to both hot conductors on the output. What I have done in the house before I came back out here was turn off all of my 240 volt stuff. I turned off the range, I turned off the dryer, I turned off my air conditioner, so only 120 volt loads are, breakers are on in the house. So we will connect this to Apex and connect it to the house. We'll start with the house side first. Twisted. And this will go into the TT30 plug. And we will turn on AC output. And I did go and switch my refrigerators, my garage stuff, almost everything that was running on the AC 500, I switched to utility power. So we're going to see that load come on here. So it's going to fluctuate. Let me see if we can switch the Apex. No, it caught it up. 1.2 kilowatts, 532. Okay, it's showing a reasonable load. So it's currently running most of my house. It's a sunny day. We're almost breaking even on solar, but let's say we aren't, or charge is getting low and we want to bring some more energy into the system. That's what the generator is behind me is for. So let's hook that up. Okay, so the standard AC input cord of Apex is your normal computer C13 to straight blade. And I've got a little extension cord here so we can hopefully reach. So we're gonna do that first and charge off generator. I'm gonna scoot it back a little. And it's a Honda, so I'm hoping for good things. There we go. So Apex sees it and is currently charging at 551 watts, 530. Let's go see what our charge settings are. Standard. Oh, you know what? I don't have it set. I have it in PV priority. Let's set it to charge. There we go. 1600 watts. So now we're charging off the Honda at its full rated capacity. And the Apex can actually deliver in 120 volt mode. It can deliver 3,840 watts. So what we're doing is pulling it in a constant rate, both from solar and from the generator. And we are outputting whatever the house needs, and we're charging. But if the house wants more, the house will take more. The house will take a lot more. Kind of neat. What if this isn't enough? What if you want more power? I've got a cord for that. Let me shut this off. And we're back. So what I have here is the optional 30 amp 120 volt AC input cord. It has a TT30 on the end of it and the new special plug. So I'm going to put a TT30 to L530 adapter on it. I also have my second Honda, and I've hooked them up in parallel with the connection kit. It has a L530 30 amp outlet, so that's why the adapter. So we're going to connect this up. Oh, by the way, this connector has this new special sort of twist lock push to connect. It is very nice. So we're going to put this on Apex and fire up the generators. Just push and click. Twist lock. Okay, and we are charging. Still charging at the same 1.6 kilowatts, but that's because I set the amp limiter. Let's go in there and see what we get when we set the amp limiter up. Advanced settings, max grid input, 13. I'm not going to let you see this part here. Password. All right, so we are in Pro mode. Oops. Let's turn the amps up. 20 amps. And what do we have now? 2.4 kilowatts input. These Hondas will do 3,200 watts continuous combined. 26 amps, I believe. So let's turn it up. Advanced settings. 26 amps. They just revved way up. $31.01. Let's get a little more. $28 amps. So according to the screen of Apex, 3339. So that's what the generators will do by themselves. The Apex can still charge at more from this 30 amp input. So it's a sunny day today. I'm bringing in solar. I'm bringing in generator power. I'm running most of my house. Who cares if the power comes back? Thanks for watching.